Welcome to my channel RAVIKUMAR Academy. This is a lecture series on single variable calculus. In this lecture, we are going to learn Rolle's mean value theorem and we are going to solve some problems related to Rolle's mean value theorem. Coming to the Rolle's mean value theorem statement, it states that if f is a function such that f is continuous on closed interval ab, f is differentiable on open interval ab, and f is satisfying f of a equal to f of b, then there exists at least one number c in between a and b such that f dash c is equal to 0. So, this is the statement of Rolle's mean value theorem. Now, we are going to solve some problems related to Rolle's mean value theorem. Let us take the first one. Verify Rolle's mean value theorem. Rolle's mean value theorem for f of x is equal to x plus 2 whole cube into x minus 3 whole power 4 in the interval minus 2 comma 3. So what we have to do when you are asked to verify the Rolle's mean value theorem, whatever said in Rolle's mean value theorem is true. That is what we have to verify. That means if the given function satisfies these three conditions, then we must be able to find a c that satisfies f dash c equal to 0. If the function does not satisfy any of these three conditions, then we cannot apply Rolle's mean value theorem for that particular function. Right? So we have to verify, first of all, these three conditions are satisfied or not. What is the function that is given? It is x plus 2 whole cube multiplied by x minus 3 whole power 4. Right? And what is the interval that is given? It is minus 2 comma 3. So x belongs to minus 2 comma 3. If you expand x plus 2 whole cube, you will get a polynomial of degree 3. And if you expand x minus 3 whole power 4, you will get another polynomial of degree 4. So when you multiply these two, you will get a polynomial of degree 7. So the given function is nothing but a polynomial. It is a polynomial. You should remember this point. Every polynomial is continuous, differentiable, integrable, everything. A polynomial is a very good function that is always continuous, differentiable, and integrable on any interval on the real line. So this function is also a polynomial. Therefore, since you can write like this, since f is a polynomial, it is continuous and differentiable real line, real number system real line. Hence, on minus 2 comma 3 also, because this is a part of the real line. This is a subset of real line, and the function is continuous and differentiable on the entire real line. Hence, it must be continuous and differentiable on every subset of the real line. Therefore, first two conditions are satisfied. The first condition that f is continuous, second condition that f is differentiable are satisfied. So hence we need to verify the third condition that f of a equal to f of b. What is f of a? F of a is f of minus 2 because the given interval is minus 2 comma 3, a is minus 2 and b is 3. So what is f of minus 2? F of x is x plus 2 in whole cube into x minus 3 whole power 4. You put x equal to minus 2 here, you will get minus 2 plus 2 whole cube into x minus 3 whole power 4. Because minus 2 plus 2 is 0, you will get 0. 0 into anything is 0. f of b. What is f of b? F of 3. So it is 3 plus 2 whole cube, because we need to substitute x equal to 3 in this function. 3 plus 2 whole cube into 3 minus 3 whole power 4. Again, this is 3 minus 3 is 0. Therefore, 0 into anything is 0. So, from these two, we have f of a equal to f of b. So, therefore, all three conditions of Rolle's mean value theorem are satisfied. What the Rolle's mean value theorem is stating that when these three conditions are satisfied, we should be able to find a C in between A and B such that f dash equal to 0, right? So we will try to find out that particular C and verify whether it is correct or not. We should be able to find, right? So now what is f of x? F of x is x plus 2 whole cube into x minus 3 whole power 4. From this, we need to find out f dash x, the derivative of f. It is like u into v derivative. So it is derivative of x plus 2 whole cube multiplied by x minus 3 whole power 4. So this is u, this is v. Then uv dash plus vu dash. U is x plus 2 whole cube multiplied by derivative of v, x minus 3 whole power 4 plus v into x minus 3 whole power 4 into d by dx of u. It is x plus 2 whole cube. X plus 2 whole cube multiplied by, what is the derivative of x power n? The derivative of x power n is n into x power n minus 1. Whether it is derivative of x plus a whole power n is also same. N into x plus a whole power n minus 1. Right? So whether you have x plus a or x minus a, it doesn't matter here. Therefore, the derivative of x minus 3 whole power 4 is 4 into x minus 3 whole power 4 minus 1, 3, plus x minus 3 whole power 4 multiplied by the derivative of x plus 2 whole cube is 3 into x plus 2 whole power 2. So now you can take x plus 2, here you have x plus 2 whole cube, here you have x plus 2 whole square. So you can take x plus 2 whole square as common. And in the first term, you have x minus 3 whole cube. Here you have x minus 3 whole power 4. The minimum of 3 and 4 is 3. So you can take x minus 3 whole cube here from the both the terms. So in the first term, the constant that remains is 4 multiplied by, we have one more x plus 2 here. We have taken x plus 2 whole square. So you have one more x plus 2. It is x plus 2 plus in the second term it is 3 into x minus 3 whole cube is taken out. So you have another x minus 3 as a factor here. So it is x plus 2 whole square multiplied by x minus 3 whole cube multiplied by, it is 4x plus 8 plus 3x minus 9. So you can write this as x plus 2 whole square into x minus 3 whole cube multiplied by 4x plus 3x 7x 8 minus 9 minus 1. So this is the derivative of given function f of x. So this is the crucial part in this problem. In any Rolle's mean value theorem problems, finding the derivative is only important thing, difficult one. So once you find the derivative, what we are expecting is we should be able to find a C in between minus 2 comma 3 that satisfies f dash c is equal to 0. So we start with f dash c. Suppose f dash c is equal to 0 for some c in between minus 2, 3. Then what should happen? Substitute x equal to c in f dash x. What you will get? X c plus 2 whole square into c minus 3 whole cube into 7c minus 1. C plus 2 whole cube whole square c minus 3 whole cube into 7c minus 1 equal to 0. So from this, either c plus 2 is 0 because the product of three numbers is 0 means either of the numbers is 0, or c minus 3 equal to 0, or 7c minus 1 must be equal to 0. But what Rolle's mean value theorem is stating that you should be able to find a c in between minus 2 and 3. It should not be equal to minus 2 or minus 3. Sorry, minus 2 or 3. So c cannot be minus 2, c cannot be minus 3. When open interval means what? Minus 2 and 3 do not belong to this interval because that is why it is open interval. When you write like this, minus 2 comma 3, this is closed interval. Minus 2 and 3 belong to the interval. When you write like this, it is open interval. So c equal to minus 2, which does not hold. C equal to 3, which we cannot take it. So we should be able to find in between. So from the third one, 7c minus 1 equal to 0 implies 7c equal to 1. That implies c equal to 1 by 7. So 1 by 7 is a quantity that belongs to minus 2 and 3. Yes. So whatever Rolle's stated is true. Therefore, now we are able to find such a C. Our aim is achieved. Our goal is achieved, right? Therefore, hence, Rolle's mean value theorem is verified. Rolle's mean value theorem is verified for this function, right? Now, we'll take one more problem. Fx equal to mod x minus 2 in the interval minus 3 comma 3. Here, the given function is mod x minus 2 is like fx equal to mod x minus a. So you should remember this. This is a special function. Uh, fx equal to mod x minus a. Suppose this is a, then its graph looks like this, right? V shape. It looks like V shape. So it comes like this, and so it bends at a. It has a sharp bend at a. Remember, whenever you have a function curve that has a sharp bend at a particular point, there the function is not differentiable. If the function is like this, it is not differentiable at this point at sharp bends, right? So therefore, this function is also not differentiable at x equal to a. So the given function is not differentiable at x equal to 2. But the important thing is whether this point 2 belongs to the given interval or not. That is important. Yes. X equal to 2 lies in this interval. Yes. Therefore, in the given interval, we have a point where the function is not differentiable. Right? If it is not differentiable at x equal to 2, Rolle's mean value theorem cannot be applied to the function f, the given function f, right? So you need not check whether out of three conditions, if one condition fails, we cannot apply Rolle's mean value theorem for the given function. So you need not check about the other two. In fact, the first condition that f is continuous is true. There is no breaks in the function. graph. Therefore, it is continuous everywhere, but it is not differentiable at x equal to 2. Okay. So coming to this function y equal to e power x into sin x minus cos x in pi by 4 comma 5 pi by 4 interval, verify Rolle's mean value theorem for this function. So here the function f of x is e power x into sin x minus cos x, and the interval is pi by 4. In fact, it is given as closed interval 5 pi by 4 is the given interval. Now, whether this function is continuous or not, yes, because you remember this polynomial, every polynomial, exponential, and sin x and cos x, so they are always continuous and differentiable. You need not check. Okay, these four functions are always continuous and differentiable. So everywhere, and also everywhere. So since e power x, sin x, and cos x are continuous and differentiable, so is f, right? Therefore, the given function f, which is a combination of exponential, sine, and cosine, are also continuous and differentiable, because the product of two continuous functions is continuous. Sum and difference of two continuous functions is also continuous, right? Also for differentiability. So therefore, first two conditions are satisfied. Now, coming to the third condition, what is f of a? We need to check whether f of a equal to f of b. F of, what is a? A is pi by 4. So this is e power pi by 4 into sin pi by 4 minus cos pi by 4. And what is sin pi by 4? It is 1 by root 2 minus cos pi by 4 is also 1 by root 2, which is e power pi by 4 into 0, which is 0. And coming to f of b is f of 5 pi by 4. It is e power 5 pi by 4 into sin 5 pi by 4 minus cos 5 pi by 4. But e power 5 pi by 4 into, what is sin 5 pi by 4? It is sin 5 pi by 4 is sin pi plus pi by 4. Sin 180 plus theta is minus sin theta. So it is minus sin pi by 4. So it is minus 1 by root 2. Coming to cos 5 pi by 4, it can be written as cos pi plus pi by 4. Cos 180 plus theta is minus cos theta. Minus cos theta is minus cos pi by 4. It is, you already have a minus here, so it becomes plus 1 by root 2. So again, you will get e power 5 pi by 4 into 0 multiplied by 0, you will get 0. So therefore, f of a is equal to f of b. Therefore, f of a is equal to f of b. The third condition is also satisfied. Therefore, all three conditions of Rolle's mean value theorem are satisfied. So therefore, there must exist a c in between pi by 4 and 5 pi by 4 according to Rolle's, such that f dash c is equal to 0. So we try to find such c. So we start with f dash c. Before that, we should be able to find the derivative of f. What is fx? F of x is e power x into sin x minus cos x. So what is f dash x? F dash x is, this is uv, you take it like uv, u, and this is all v. Then uv dash plus vu dash is the derivative. U means e power x. V dash means the derivative of sin x minus cos x. Sin x derivative is cos x minus cos x derivative is minus sin x. You will get plus sin x here. Plus vu dash. V is sin x minus cos x into u dash is the derivative of first function e power x is e power x only. So now you can take e power x common. It is cos x plus sin x plus sin x minus cos x. Cos x gets cancelled. It is e power x into 2 sin x. So this is f dash x. This is f dash x. Now let us consider f dash c equal to 0 for some c. Then what should happen? E power c into 2 sin c must be equal to 0 because f dash x is e power x into 2 sin x. F dash c is substituting c in place of x. You will get e power c into 2 sin c, which is equal to 0. So either e power c is 0 or sin c is 0. But remember, exponential function is never 0. Right? So exponential function is never 0. But e power c is not equal to 0. Hence, we must have sin c equal to 0. So remember this, the exponential function is never 0 for all x. For any x in the real line, exponential function is never 0. So that is why sin c must be equal to 0. This implies c must be n pi, where n belongs to z. So n is any integer. So c equal to n pi means, but the thing is we must be able to find c in between ab, open interval ab, right? So we should be able to find, so for what value of n, you will have a c in between pi by 4 and pi by 4. It is, put n equal to 1, you will get c equal to pi. So pi is in between pi by 4 and 5 pi by 4, right? Because pi by 4, because 5 pi by 4 is pi plus pi by 4. So it is more than pi, right? And pi by 4 is less than pi. Therefore, c equal to pi belongs to 5 by 4 and 5 pi by 4. So we are successfully able to find a c in between pi by 4 and 5 pi by 4 that satisfies f dash c equal to 0. So whatever Rolle's as stated is correct. Therefore, hence Rolle's mean value theorem is verified. It is verified to be true. Verify Rolle's mean value theorem. So for this function fx equal to x square plus 1 in between 0 and 1, 3 minus x in between 1 and 2. The whole interval is actually 0 and 2. It is divided to be two intervals, divided into two intervals 0, 1 and 1, 2. So in the interval, first interval 0, 1, the function is x square plus 1. In the second interval, the function is 3 minus x. That is how we have to deal, right? So there is a break actually. But what about the continuity? So there is a break at x equal to 1. That means the function is actually split. But we need to check the continuity, right? So we need to check continuity at x equal to 1. What is f of 1 minus? That means 1 minus means what? To the left hand side of 1. Whenever to the left hand side of 1, it is, you have to take this function. So 1 square plus 1, it is 2. To the right side of 1, it is 1 plus, it is 3 minus x we should consider whenever We are dealing on the right hand side of 1. It is 3 minus 1. It is 2. So continuity, there is no problem with continuity. So we need to check whether it is differentiable or not. For that, we try to find the left hand side derivative and right hand side derivative at x equal to 1. Remember, we need not check at any point. We need not check the differentiability or continuity at any point to the left hand side or any point to the right hand side, because to the left hand side, in between 0 and 1, at every point the function is only x square plus 1. It is a polynomial. Every polynomial is continuous and differentiable. To the right side of 1, the function is 3 minus x. Still it is a polynomial and it is continuous and differentiable, right? So at x equal to 1, because the function is given as two parts, before to the left hand side of 1 and to the right hand side of 1, we need to check whether the differentiability carries out or not, right? So for that, we find left hand side derivative at x equal to 1. What is the left hand side derivative at x? At any point x, it is limit h tends to 0 f of x minus f of x minus h by h. So this is the formula of left hand side derivative, because we need to check whether x, x minus h and x plus h. So here f of x and f of x minus h we need to check. That is left hand side derivative. At x equal to 1, we are going to check at x equal to 1. Therefore, left hand side derivative at x equal to 1 is limit h tends to 0 f of 1 minus f of 1 minus h by h. So remember, because we are finding the left hand side derivative at x equal to 1, we should consider the first function as f of x. So you are finding f of 1 means you take x equal to 1 in the left hand side function. So it is 1 square plus 1 minus, you substitute 1 minus h in place of x, you will get 1 minus h whole square plus 1 divided by h. So it is limit h tends to 0, it is 2 minus, inside the brackets it is 1 plus h square, a minus b whole square. 1 plus h square minus 2h plus 1. This is limit h tends to 0, 2 minus, I am writing it again, 1 plus h square minus 2h plus 1 by h. So continuing from here, it is limit h tends to 0, 2 minus, so it is 1 plus 1 is 2, again it is minus 2 minus h square plus 2h by h. So 2 gets cancelled. When you substitute h equal to 0 in this, and before substituting, you should cancel out 1h, right? Otherwise, you will get 0 by 0 form. So it is limit h tends to 0, it is 2 minus h into h by h. H gets cancelled. Limit h tends to 0, it is 2 minus h. When you substitute h equal to 0, you will get 2 minus 0, 2. So therefore, left hand side derivative at x equal to 1 is 2. Now we'll find right hand side derivative at x equal to 1. What is right hand side derivative? The right hand side derivative formula is limit h tends to 0 f of x plus h minus f of x by h. So right hand side derivative at x equal to 1 is limit h tends to 0 f of 1 plus h minus f of 1 by h. Because we are dealing to the right hand side of 1, on the right hand side of 1, the function is f of x is 3 minus x, right? So we should deal with the function 3 minus x here. limit h tends to 0, what is f of 1 plus h? F of x is 3 minus x. So it is 3 minus 1 plus h minus f of 1. If you cancel this function only, it is again 2. Right? So divided by h. So it is limit h tends to 0, 3 minus 1 minus h minus 2 by h. So 3 minus 1, 2, 2, 2 gets cancelled. Limit h tends to 0. It is minus h by h equal to limit h tends to 0 minus 1. Because it is a constant, there is no h here. So the limit value is minus 1. So therefore, left hand side limit exists and equal to 2. Right hand side derivative exists and it equal to minus 1. But LHD is not equal to RHD. Therefore, f is not differentiable. F is not differentiable at x equal to 1 because the differentiability fails. So at least one of the conditions of three conditions of Rolle's mean value theorem fails, then we cannot apply Rolle's mean value theorem. Therefore, Rolle's mean value theorem is not applicable for this given function. Right? That's it. That is the conclusion of the problem. Now we will move to one more problem. It is very important. So here the function is f of x is equal to log x is log x square plus ab by a plus b into x. Here the function is x square plus ab by a plus b into x. The interval is ab and obviously b is greater than a and that is positive. A is given as positive. So whenever the value of a and b are positive, then because inside this logarithm it is a positive quantity. So logarithm is defined, log x is defined if x is positive only, right? And because a and b are positive and x is in between a and b, x square is positive, ab is positive, a plus b into x is positive, everything is positive inside. Therefore, it is a well-defined function. Because it is a well-defined function, whenever logarithm is well-defined, it is continuous and differentiable, right? So therefore, since b is greater than a is greater than 0, that means both are positive, we have f is, that means you can write conclusion like this. F is continuous and differentiable, both open and closed intervals ab. So let us check the third condition, f of a. What is f of a? So a is not given as a number. Directly you can substitute a in place of x. Then you will get log a square plus ab. When you substitute a in place of x, a square plus ab divided by a plus b into x. When you take a common in the numerator, you get a into a plus b by a plus b into a. So you will get log 1, which is 0. Log 1 is 0, right, for any base. Similarly, if you find f of b, it is log b square plus ab by a plus b into b. So here also in the numerator, if you take b as common, b into a plus b divided by a plus b into b, you will get. So you will get log 1. Log 1 is again 0. So therefore, f of a is equal to f of b. That's all three conditions. Therefore, all three conditions of Rolle's mean value theorem are satisfied. So therefore, there must exist a C in between open interval a and b such that f dash c is equal to 0. So let us consider f dash c equal to 0. Before that, we must find f dash x. What is f of x? The function f of x is log x square plus ab by a plus b into x. So what is the derivative of log x? Log x derivative is 1 by x, right? So therefore it is like log something. Log something derivative is 1 by something. Whatever inside it is, we must get here a plus b into x. So 1 by something multiplied by, because we have inner derivative also here. Inner derivative of x square plus ab divided by a plus b into x. So this you can write it as a plus b into x divided by x square plus ab multiplied by, because 1 by a plus b is a constant, you can take it out of the derivative and write d by dx of, you divide the x square plus ab by x, you will get x plus ab by x. Here a plus b gets cancelled. You will get x by x square plus ab into, what is the derivative of x? 1 with respect to x, minus ab by x square, because the derivative of 1 by x is minus 1 by x square. Here ab is a constant, derivative of 1 by x is minus 1 by x square, ab into minus 1 by x square is minus ab by x square. So this is f dash x. This is f dash x. Now we need to consider f dash c is equal to 0. So then what is f dash c? F dash c is equal to 0 implies, what is f dash x? It is c by x square plus ab. So it must be c by c square plus ab into 1 minus ab by x square. So 1 minus ab by c square equal to 0. Right? Because c lies between a and b, c is in between a and b, somewhere in between, and a is positive, a is greater than 0, c cannot be 0. C cannot be 0 because c lies between a and b. So since c is not equal to 0, and 1 by c square plus ab cannot be, right? C is not equal to 0, we must have, this must be equal to 0. We have only possibility 1 minus ab by c square must be equal to 0. This implies 1 equal to ab by c square. This implies c square into 1 is c square equal to ab. This implies c equal to root ab. Of course, plus or minus root ab, but c is positive, so you need not take negative root ab. So c equal to root ab. And we know that the geometric mean of a and b is root ab. And the geometric mean of two numbers must lie in between those two numbers. So geometric mean of a and b must lie between a and b. So root ab lies between a and b. Therefore, c equal to this root ab satisfies our requirement that we should find a c in between a and b, for which f dash c equal to 0. Therefore, Rolle's mean value theorem is verified to be true. Once again, it is verified to be true. So this is all about Rolle's mean value theorem and problems on Rolle's mean value theorem. We have discussed all types of problems, different types of problems. All are important problems in the examination point of view, right? So please subscribe to my channel if you have not subscribed yet. Please like the video, share it with your friends and classmates. Thank you so much. Comment your feedback. Thank you.